2 is all about linear relations and functions, and what I'm about to show you on the screen you can either take a picture of or you can screenshot it from your book, and I've put the page number in case you want to do that, and then we're going to go through it and talk about what it is. This is to identify whether or not something is linear. Okay, again, it's on page 206 in your book. If you'd rather screenshot it, if you want to take a picture of the screen, you can do that too. It's up to you. There's a lot going on here, so I'll let you get that situated in your notes, and then we'll start going through it. Let's talk about what's going on here. There's a lot of parts, and I'm going to summarize it on the next slide. It'll make your life a little bit easier. Let's try to break it down. Okay, linear equation has no operations other than addition, subtraction, and multiplication of a variable by a constant. What that means is we can add a constant, which is just a regular number, no variable, with a variable, and it can be linear. We can subtract a number with a variable, and it's linear. We can multiply a number by a variable, and it's linear. You can kind of divide. For example, down here, I could rewrite this as x over 2. So you can divide when x is the numerator. What this is really trying to say is that a variable cannot be a denominator. Okay, you cannot divide by a variable. You cannot have that in the bottom of a fraction. It can't be a divisor of a division problem. That's what it's trying to say there. Variables may not be multiplied together or appear in a denominator, like I just got done saying. They also can't be in a radical. And they have to have a power no greater than 1. Okay, so if you notice over here, these are examples of linear equations. The powers on the variables are 1. There are no variables in denominators, there's no variables under radicals, and no variables are being multiplied together. In order to prove that something, or to demonstrate that something is linear, you have to state all of those things. When it's not linear, it's super easy. You're like, look, there's a variable with a power greater than 1. Can't be linear. There's a variable in a radical. Done. Can't be linear. 2 variables are being multiplied together. Can't be linear. We have a variable in the denominator. Can't be linear. Okay? Bottom line is, when it's not linear, it's super easy. You just have to point one of those things out. If it is linear, you have to state 4 different reasons why it's linear. And that's on the next slide. Okay? What's this form down here? Slope-intercept, right. Sometimes you see it written like this with a y instead of f of x. So what it's saying is if you can eventually put it into slope-intercept form, then it's linear. Okay? So all of that has to be true. So on the next page here, these 4 things are what you have to write in order to show it's linear. So if it's linear, all of these things have to be true. There's no variable raised to a power bigger than 1. There's no variable in a denominator. Let's change that. Oh no, we can leave it. It's fine. No variable is a denominator. I'm good with that, actually. No variable is under a radical. No variable is multiplied by another variable. So when you get to your homework and it says, decide if the following are linear. If you decide that that's linear, this is what you have to say. And so in your homework, and on your quiz, and on your test, you're going to say, it's linear because of all 4 of these things. It's sort of like that situation with the determining if it was a function using the vertical line test. It's so much easier when it's not a function, because you just draw the vertical line and say not a function. But then when it is a function, you have that long, lengthy explanation. The same thing is true for linear. If it's linear, you have a long, lengthy explanation. If it's not linear, you just pick the one that this one violates, and you're good. So besides slope-intercept form of a linear equation, we have another form, and that is standard form. And standard form comes like this. A, B, and C represent constants, regular numbers. Okay? So you have the x and y on the one side, and the constant without the variable on the other side. This should always be how it's listed for standard form. Sometimes it's also called general form. Same thing. There are some conditions on A, B, and C. And here are those conditions. And this is where knowing your number sets is important. A must be a whole number. So that means A must be what kind of number? Positive, not negative, basically, non-negative. And what other kind of number is it?
Natural.
Huh?
Natural.
No. If it's whole number, that means it can't be what? Besides negative, it can't be what? Decimal? What else can it be? Fraction. Okay, it can't be a fraction, can't be a decimal, and it can't be negative. That's a whole number. B and C are integers, which means it can be negative, but still no fractions or decimals. Okay, so ultimately, standard form means the first term's not negative, and there's no fractions or decimals. Now, that's standard form. That's not to say that you could have an equation that has those things in it and it's still linear. There's nothing wrong with it. It's just not in standard form. Okay, that's the difference. Now, I'm going to give you 5 equations. They're all linear. And I want you to decide which ones are in standard form. Don't say them. Just write down the ones that you think are, well, write them all down. But then circle the one that you think is in standard form. Okay? Or the ones that are in standard form, I should say. Okay, so here are 5 equations. Circle the ones that you believe are in standard form. Go. Show of hands. How many think 1 is in standard form? How many think 2 is in standard form? How many think 3 is in standard form? How many think 4 is in standard form? How many think 5 is in standard form? Alright. Well, the correct answer is, that's the only one. Number 1 is the only one in standard form. Okay? Let's think about that. Did anybody say 1 was the only one? Ooh, 4 of you. Very good. So, A must be what? Positive. So that immediately throws out 2. X isn't even on the right side for 3. X is supposed to be over here. Well, yeah, but right now it's not in standard form. What's the problem in 5? Fractions. Alright, so here are the 4 that were not in standard form. So to your question, Abby, can't we put them in standard form? Absolutely. Put them in standard form. Go. What is the problem with this first equation here?
It's negative.
Okay, so how do I make this not negative? Yeah. Divide by -1, multiply by -1, change all the signs. Okay, either one of those is fine, because changing the signs is the same as dividing or multiplying by -1. How many had that? Very good. Okay, the second one, what's the problem? Slope-intercept form, okay? Which is fine, except we're supposed to be in standard form. So what needs to change here?
Subtract 6x and then times by -1.
Negative 6x plus y.
No, just add the
Alright.
and then subtract
Okay,
y.
so very good. That you said there are a lot of things that you said that were good. If I move the 6x to the other side, it's going to become negative, and I'm going to have the same situation as I had over here. Okay? So instead, what I'm going to do is I'm going to take the y and move it over there, and then I'm going to take the -9 and move it over there, and then I'm going to flip the whole thing. So 6x stays positive, y becomes negative, and 9 becomes positive. 6x minus y equals 9. How many had that? Okay, good. What has to change on this one?
You have to add the 8x.
Yep. Just add the 8x to the other side, or slide it over and it changes the sign. 8x plus 2y equals 10. How many had that one? Alright, last one we have to multiply by the common denominator, which is 15. So I get 5x plus 6y equals 105. How many had that?
Yeah.
Very good. So there are your 4 equations now in standard form. Okay? Bless you. That is something you're going to have to do in your homework today. Okay? Questions so far?
Pretty easy, I'm not gonna lie.
So far. The next thing we need to talk about are x and y intercepts. Okay, we talked about making a table of values to graph a line the other day. In a few days we're going to talk about using slope-intercept form to graph a line. Today we're going to talk about using x and y intercepts. What is an x-intercept? Yeah.
Where the line intersects the x-axis.
Where the line intersects the x-axis. Okay? Pretty similar to my definition. The x-intercept is a point where a graph intercepts the x-axis. That's why it's called the x-intercept. It intercepts the x-axis. Now,
Y is opposite.
what does it mean? What do we know about the point, or any point for that matter, that, because what we're saying here is we're talking about a point that lies on the x-axis. Okay? It is on the x-axis. What is true about that point?
It's X.
What?
Oh yeah.
The y will be 0. If it lies on the x-axis, the y value must be 0. Hence, and this is where it sort of flips on you a little bit. A lot of the times when you guys do the x-intercept, you like to make the x 0. Well, it's not like that. The x-axis, the equation for the x-axis is y equals 0, which means every point on that axis has a 0 coordinate for y. So when we talk about the x-intercept, because you can cross the x-axis in an infinite number of places, but every time that that happens, the y coordinate is going to be 0. This is important because since the y coordinate is always 0, it's easy to find the x-intercept when we have an equation. Okay? So the next two lines, you know what they are. Right? What's the next line going to say?
That the y-intercept is a point where the graph crosses intersects the y-axis.
Okay.
One boy.
Very good. That was very good. The y-intercept is a point where a graph intercepts the y-axis. Okay? So it lies on the y-axis, which means what value do we know?
The X is 0.
The x now is 0. So it flips on you. The y-intercept, we know that the x is 0. The x-intercept, we know that the y is 0. So you know the next line too here. Okay? X value of that point equals 0. So the y-intercept will always be in the form 0, comma something. Which again, makes it easy to find when we have an equation. Here's the type of problem that you're going to be looking at for homework. You're going to have something like this. It will say graph the equation, and I give you a linear equation in standard form using the x and y intercepts. So you're going to specifically have to find the x and y intercepts, which should not be bad, because if I'm looking for the x-intercept, what do I know? Y is equal to 0. So if I'm going to do that, I can take a table of values, just like this. I know that y has to be 0 for the x-intercept, so how do I find what the x-intercept is? Plug 0 in for
Y.
and solve for x, so do that. Now I gave you a nice one, okay? I gave you a nice problem where the numbers turn out nice. What is the x-intercept? Okay, so one of the things I want to be sure of is that you don't stop here. Okay, I go back up top and I fill in the 5. The x-intercept, remember, is a point. Don't just stop and say x equals 5, because that doesn't work. If you wrote x-intercept equals 5, that's one thing. But my preference is that you write it as a point. just like this. X-intercept 5, 0. Okay. Now, I need to do the same thing. Well, not quite. If I'm going to find the y-intercept, what am I going to do? 0 in for x. So do that. So same idea, except now I plug 0 in for x and solve. Alright, what is it? Negative 2. And again, same thing. Write it as a point. 0, negative 2. Now my problem asked me to graph. So go ahead and grab one of your grids that you used. You probably have it in your photos. You can insert your grid in there and graph this equation using those 2 points. And when you're done, take a look at the screen and see if you did it right. A couple things I want to point out. Make sure when you graph your lines that you put arrowheads on the end. Don't just give me a line segment. Don't just assume that I know you know that it's supposed to keep going. If you put the arrowheads on it, then you'll know. Okay? What's the domain for this function? All real numbers. How about the range? Is this a function? How do you know? Okay, that's one way. No vertical line will ever hit more than 1 point. Now, we don't have all the points, so that's probably the only way you're going to be able to determine that this is a function. Okay? So vertical line test is probably going to be your best bet. So this is a function. 1-to-1, onto, both, neither? Both. Okay. Continuous or discrete? Continuous. Very good. Any questions?